wait, this is a plus and this is a minus. Well, let's see if we made a mistake. Let's check really, really quickly. What do I know that P of 0 is? I know that P of 0, if I put 0 in for t, then e to the negative kt becomes 1, right? Because negative k times 0 is 0, e to the 0 is 0, k can't be infinity, so we don't really worry about this. So that implies that, what do we get? We know that this is going to be k over 1 minus a, and this is going to equal p naught, right? Well, again, let's just do a touch of algebra here. I'm going to solve for a because I'm a little disconcerted here because I got a negative here and I got a positive here. Let's look. If I solve for a, let's see what happens. I get k equals p naught minus p naught a, right? If I add this over, right, because I'm solving for a, and I don't like negatives, so I know that p naught a plus capital K is equal to p naught, right? So I know that this implies that p naught a is equal to p naught minus k, which, oh, I'm so out of room. All right, you guys, I apologize for this work right here, but I don't want to turn pages if I don't have to, which implies that a equals p naught minus k divided by p naught. Now look close. I have this a, this is the a that I created. Let's change colors. I've got this guy. What do you notice about the difference between these two a's? Notice this one is k minus p naught over p naught. This is p naught minus k over p naught, which implies we could factor out a negative. So again, oh, I wish I had a little more room. Just a little more room. I don't ask for much. All right, so what do we know? We know that P of t equals capital K over 1 plus a e to the negative kt, where a equals, well, what does it equal? Let's make sure. When we're in this form, we know that it's k minus p naught over p naught. So it's k minus p naught over p naught. Now remember, through my differential equation, I ended up with P of t equals k over 1 minus a e to the negative kt, right? But a, let's go, but a equaled p naught minus k over p naught, which is exactly the same thing as negative times k minus p naught over, whoops, it should be a p naught, over p naught, right? I could divide that negative through and end up with a negative a. So really, these guys are equivalent. They're the same thing. The standard form, excuse me, is this guy. All right? And that's where it comes from, ladies and gentlemen. You now have proof that the logistics equation comes from this differential equation. Now that's going to become important to you guys, because whenever I see this differential equation, there's a little bell that goes off in my head and says, whoa, 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 that's logistics. I'm going to play with that guy. Now, before we're done, let's talk about where logistics equations are useful. Where / y logistics equations. Logistics equations. All right. Well, the easiest to see is population. Population. All right. Clearly, population runs out of something, starts to die off, starts to have disease, starts to have predation, et cetera, et cetera. Now, why do you think they use the word logistics? Where have you heard of logistics before? Hopefully, you've heard of it in business. Now, think about the business model. Okay? Business. Think about the business model, right? Think about iPods when they first came out. What happened? At t equals 0, what happened? A dude showed up with a little tiny little box that could play every song that they ever wanted to have, right? And everybody said, whoa, where'd you get that? And they said, I got it from Apple. And then what happened? Everybody had to have one. Oh my God, I got to have one. Oh my God, I got to have one. And then what happened? Well, everybody started to have one. So the rate at which people were buying iPods began to decrease. And the number of people, the population of people that had iPods, am I dating myself by saying iPods? You're going to do this for iPhones or iPads or whatever, began to head for the carrying capacity. And the carrying capacity was whatever the market would bear, right? Does that make sense? So, we know that Steve Jobs is a relatively bright guy. So what did he do? What do clever businessmen do? This is a little bit of an aside. What they try and do is they try to predict where this point at which the rate of increase of P of t begins to decline, begins to decrease, and then they start thinking up what? They start thinking up a new product. Let's bring out the iPod 2. It'll be bigger. It'll be better. You can do apps on it. And that starts off a whole new curve, right? Some of these people that have iPods want the iPod 2. People that don't have iPods at all might want the iPod 2. Well, where do we want to start thinking about that? What do you notice about that point? That point is critical. No pun intended. It's called the inflection point, right? That's when things start to change. That's when we start to increase. We go from increasing at an increasing rate, or growing, right? That's called growth, versus increasing at a decreasing rate. Now we're still growing, but we're not growing as quickly. And business people are always concerned about big growth. All right, the last one, probably my favorite, you're going to do a problem like this in your homework, is the spread of a rumor. Think about a rumor. Oh my gosh, did you hear what Jimmy Jen and Jenny Jane did at the party? I can't believe it. It was crazy. One dude or a lady, don't mean to be gender biased, sees the horrific event, and what happens? They tell a couple friends. And what happens? They tell a couple friends. Tell a couple friends. What happens right here? People start rehearing the rumor. They're like, what? I already heard this rumor. This is lame. That's last week's news. Until what happens? The carrying capacity, which in this case, depending on what school, Jim, whatever the heck their names were, is the school or anybody who cares to know what these two people did. This carrying capacity is when 100% of the people that care know the rumor. Spread of rumor. And if it works for rumors, guess what else it works for? Disease. Spread of disease. It's a great model for those. Okay? All right, well, cool. That ends this lesson. I hope you enjoyed it. It also ends the chapter, so work hard for me. We're getting near, man. We got one more chapter to do, and then it's off to the races. Start preparing for the CBEs and the APs. So thanks for your time and attention, and have a really good